right, guys, we are moving into the last section of this week, lesson 10.7, and we are talking about graphing linear inequalities. So this is just like graphing using the slope-intercept and the slope. We've also learned how to graph using the x and y intercepts. If you need to review that, that was something we did in class. But we are going to use slope-intercept form for all of these. Our essential question, can you graph linear inequalities in two variables? The way that I'm going to teach you this is by solving everything for y. You guys like solving like that anyway. So if I was to do that for example 1, I would subtract 3x to each side, and y is less than or equal to negative 3x plus 3. All right, so if I was to graph this, let's pretend that was not an inequality. Let's just pretend that that was an equal sign. We would start by graphing the plus 3 first. So up 1, 2, 3, we would put a dot. And then remember the slope tells us to go down 3 over 1, down 3 over 1. Now, we do have to learn some information on less than and equal to. So I'm going to show you how to graph this one, and then we'll go from there. When I graph y is less than or equal to, because it's equal to, we are going to make a solid line. So although mine is very sloppy, I'm going to make it solid. And because it is less than, notice I'm only looking at the y. To go less than down the y, these are the numbers smaller on the y. So I'm going to graph everything underneath the line. So we're actually only looking, we solve for y, so we only look at the y line. I'm going to stay on my graph here for you. And we're going to go ahead and graph everything on the y. So we solve everything for y to make it easy to see how to graph. So let's look at a few more scenarios and what happens. What if y is less than 1? Well, you have to remember your Hoy Vux, and I'm sure a lot of you do. Hoy Vux. Because this is a Hoy, I know this is a horizontal line where the slope is 0 and it's going to touch the y. So this is a horizontal line where it touches 0. Now notice it is not equal to, so I just made a little boo-boo. This actually has to be a dotted line. So I'm going to draw a dotted line. And if y is less than, remember I'm going to shade everything smaller going down on the y-axis. So we always solve for y unless it's an x equals only. And that is what this y is less than 1 will look like. All right, moving on. What if I have a Vux? On example 3, I have x is greater than or equal to 2. Oops, that's a negative 2. If x, we know this is a Vux, it's going to be a vertical line, a slope of undefined going through the x. At negative 2, it's going to be a vertical line. And we know if it says that x is greater than or equal to, it is going to be solid because of the equal to. And if it is greater than, I'm going to shade everything greater than. So I'm going to shade all of this that is greater than x. Because now this time it only has an x, so we have to actually look where x is greater than. All right. This one gets a little bit tricky. This is our last one, and we are going to solve for y. My first step in solving for y is subtracting 3x to each side. Negative 2y is greater than or equal to negative 3x minus 4. And if I divide everything through by negative 2, what am I going to do with that inequality? It is now greater than or equal to, but because I'm dividing by a negative, I have to flip it. So now I have 3 halves x plus 2. y is less than or equal to 3/2 x plus 2. We're going to start on 2 on the y-axis and put a dot. And we're going to go up 3 and over 2 and put a dot. I could also go down 3 and to the left 2 and put a dot. But for me, you only really need 2 dots to make a line. And since y is, I'm going to change colors here. Since y is less than or equal to, I'm going to draw a solid line going through all my dots. And since y is less than, I'm going to shade everything down the y-axis where y is less than or equal to. All right, so that's how you graph inequalities. I hope you guys get a little practice in, watch a few videos, and have a great week.